Good morning, everyone. I am Joel Philip D. Lamela, a Bachelor of Science in Electrical Engineering student from Iloilo Science and Technology University. Today, I will be discussing a video summary of Module 7, which entails about microprocessor. So this will be about the process of how the chips was made, the developments of chips, the pin through hole, the interposer, 2.5D and 3D technology, the interconnect, and wafer level packaging and panel level packaging. Now, I will discuss the process of making of the microprocessor chip. First will be the design process. The design are made by the fabless companies. Companies such as Nvidia, Qualcomm, and Xilinx are the one that will design the microprocessor and its aspects. Next will be the manufacturing of the microprocessor chips. The foundries are the one in charge in manufacturing of the microprocessor chips. They will be the one that will make the wafer and print the chips. After the manufacturing, they will go to the OSATs. The OSAT is the outsourced assembly and test companies. They will be the one in charge in the packaging and testing for the microprocessor chips. They will return back to the fabless companies for the customer service or the selling of the microprocessor chip in the market. While the IDM or the integrated device manufacturers do everything for themselves. They design, they manufacture, package, and they are also in charge of the customer service. These companies are Intel and Texas Instruments and others. Now we will discuss the development of the chips. From the first generation, the system on chip. The system on chip was designed by the fabless companies and it is a whole system on chip. It has a great power usage and power efficiency and was made by the fabless companies. Next, in order to compete with the SoC, the OSATs and the foundries made the MCM or the multi-chip modules. This was found in the 1980s and uses 2.5D technology. It is not as compact as the SoC and it has a simple design yet it is more functional than the SoC. After the system in package was created, it uses a silicon substrate and it is a stacks of chip horizontally and vertically. So it is the highest density of the transistors and has passive components such as resistors, transistors, and etc. System on package. The system on package is still in development, which the passive components are embedded on the substrate and it has SIP and SOC on the top of it. It has a number of functions and the highest technology above all. Next will be the pin through hole technology. So the pin through hole technology uses pin is inserted into a socket or is soldered. The first generation of the pin through hole technology is the dual inline package, which was made in the 1970s. This has 4 to 64 pin count and it is larger than die. Next is the single inline package, which was also created in the 1970s but is less popular than the dual inline package. After that, the quad flat package was created in the mid 1970s. It is used in integrated circuits and printed circuit boards. It has increased the numbers of pins and transistors in its package. Next will be the PGA or the pin grid array. The pin grid array is put directly into the socket and it is more cheap but also more fragile compared to the other. Lastly is the ball grid array, which was developed in the 1990s. It uses solder balls in its component to connect it to the chip. It is standardly used for computer chips. Now it is used in iPhones and Intel processors and others. We will proceed to the interposer. The interposer is a layer between the substrate and the die. So here are the interposers, the black line that connects the wiring, which serves as the wiring for the components. The most famous kind of interposer is the silicon interposer. So there are three parts of an interposer: the TSV, the RDL, and the UBM. The TSV or the through silicon vias is the vertical path of the interposer. The RDL is the horizontal path or the redistribution layer. Next is the UBM or the underbump metallization, which connect the solder bump to the RDL to stop the diffusion. The types of the interposer are the passive interposer and the active interposer. Here is the example of the passive interposer, while here is the active interposer. The active interposer has active components under its chip, which is connected to the chip, while the passive interposer has no active components under it. Now we will proceed to the 2.5D and the 3D technology. So it all originated in the 2D package, which proceeded to the 2.5D and the 3D. The 2.5D is the interposer is between the SiP substrate and the die. It uses the TSV and RDL to connect to the die, which is a horizontal integration of the chips. Next is the 3D technology, which are the chips are stacked vertically and horizontally. Some examples for the 2.5D are the Xilinx Vertex 7 2007 and the Google AlphaGo, while for the 3D are the Sony PSP 2004, which is the first use of the 3D technology, and the iPhone 5S motherboard. Now we'll proceed to the interconnect. There are three types of interconnect: the wire band, the flip chip, and the interposer. The wire band uses wires to connect the die to the packaging of the microprocessor. Now, while the flip chip uses solder bumps to connect the die to the packaging of the microprocessor. While as we discussed, the interposer uses silicon strands, which is the most popular, to connect the die to the packaging. Now we will discuss wafer level packaging and panel level packaging. The standard now used is the wafer level packaging. It has higher yield and lower cost. It uses fan-in and fan-out technology and a standardized process, while the panel-level packaging has much higher yield and much lower cost than the wafer-level packaging, and uses fan-out technology. But it is not still standardized yet. That is why it is hard for it to be created. So a closer look, this is the wafer-level packaging. The dies here that are cut will not be used in the wafer level packaging, which is not practical. But in the panel level packaging, all the dies will be used and none will be cut, which will have better results than the wafer level packaging. But there is no standardization for the panel level packaging. This is a new tech, so the wafer level packaging is still used today. That ends our presentation. Thank you.